I'm going to introduce Samantha. Samantha uses she, her pronouns, and she is a student in the Menard Lab at Queen's University, and she's going to be talking about the very important topic of the well-being of lab animals.
Thanks for the intro, Tara. My talk might be a bit of a change of pace with respect to applying more so to behavioral neuroscience employing animal models rather than pure cognition, but I'm excited to share these findings with you. So I'll just dive right in. So as many of you probably know, there is a long history of using rodents in neuroscience research. Now, a longstanding practice is to use basic standardized housing systems for laboratory animals. This has typically involved housing rodents either singly or in pairs in a cage that contains bedding and really nothing else. However, it's become more and more recognized that these barren housing conditions can have adverse effects on animals and their well-being. And because of this, it's become really common for many research facilities to supplement the animals' home cages with these things called environmental refinements, which frequently means providing species-appropriate items within the home cage, for example, nesting material, toys for chewing on or playing with, so the animals feel safe but engaged in that home cage environment. However, these refinements have been implemented without empirical validation of their effects on animals and their behavior. Now, without studies examining either of these factors, it's really unclear whether the refinement items actually do improve rodent welfare. Another critical issue concerns the reproducibility of research findings. It could be that these refinements might alter behavioral baselines, creating a divide between past and present research endeavors. So because of this, we designed a study to examine whether refinements in the home cages of laboratory rats actually do improve their well-being or influence behavioral baselines as indexed by well-validated animal models of anxiety and depression-related behavior. To this end, male rats were randomly assigned to either a refined condition or a standard housing condition. All rats were singly housed, but the cages of the rats in the refined condition contained nesting material, a hide tube, a wooden gnawing block, and a green nylon bone, which you can see on the bottom of my slide here. By contrast, however, rats in the standard housing condition were not exposed to any of these refinement items. Now, we predicted that rats in the refined condition would exhibit improved welfare as indexed by decreased anxiety-like and depression-like behavior, because that's why they've been so commonly implemented over the years. However, our results were really surprising in a lot of ways. The most startling findings we observed were in the Novelty-Induced Suppression of Feeding test, the NSFT, and the Sucrose Preference Test. So I'm going to walk you through those ones today. Now, before I dive into the findings from the NSFT, because I don't know how familiar you are with animal research, I will give you a quick run through of the test and the results we typically see. In this test, the experimenter measures rats' latencies to consume a novel treat, for example, a graham cracker, in both a familiar home cage and a novel environment. And in this test, longer latencies to begin eating the novel treat or graham cracker due to the novelty component are interpreted as heightened anxiety-like behavior. So on habituation day 1, which you can see on the left of my slide here, rats are first presented with that novel treat in their familiar home cage. Here, it's typical for rats to display latencies of around 160 seconds. However, with repeated trials in the familiar home cages on habituation days 2 through 4, and then again on that home cage test, we see rats gradually decrease their latencies to as little as 50 seconds. On the novel test day, however, rats are tested in a novel cage in a novel room, and again presented with that now familiar graham cracker. Here it's typical for rats to again display prolonged latencies of around that 160-second mark, because again, we have that added novelty component just based on that unfamiliar testing environment. Now, these behavioral predictions are in line with other literature in the field, as well as work conducted previously by other students in our lab. However, this is the behavior that we actually saw when we collapsed latencies across both housing conditions. So across all testing days, we can see that rats displayed significantly higher latencies to initiate that snack consumption than we predicted. For instance, we can see that on habituation day 1, all of the rats took approximately 310 seconds, and these latencies increased really intensely to 470 seconds during that novel cage test. This is really unusual and suggests that the rats were showing very high levels of anxiety-like behavior compared to what we would normally predict. Now, another unusual finding that you can see now that we're comparing rats between both the standard and the refined condition concerns the rats' habituation profiles. Here, the standard housed rats actually displayed the expected decreases in latencies across those trials that I mentioned previously. However, this typical habituation curve was not shown by the refined rats, and this actually led to significant between group differences on habituations day 3 and 4. So if you're, oh, sorry, I think I'm actually showing you the wrong screen still. There you go. Can you see that now? Sorry, I got ahead of myself. So if you're following me now, you can see that these were actually the exact opposite of the results that we were expecting to see, with those refined housed rats faring worse in terms of their heightened anxiety-like behavior. This unexpected pattern of behavior was actually observed again in the next test that I'll be discussing, the Sucrose Preference Test. Okay, make sure I have the right slide this time. So the Sucrose Preference Test is a commonly used animal model of actually depression-like behavior. And this test measures anhedonic-like deficits in reward processing, a core symptom of depression in humans. And in the SPT or Sucrose Preference Test, rats are presented with 2 bottles, one containing plain drinking water, the other rewarding sucrose solution. Healthy rodents do possess an innate interest in sweet solutions, hence they typically demonstrate a bias towards the sucrose. However, lack of preference for the sucrose is interpreted as a display of anhedonic or depression-like behavior. And the way we assess sucrose preference is by calculating the ratio of sucrose consumption relative to the plain drinking water, which is their sucrose preference score. So to establish whether our animals were displaying anhedonic-like behavior, we evaluated each group's mean sucrose preference score against the conventional norms in the literature. For instance, sucrose preference scores below 65% are typically interpreted as anhedonic-like, whereas being above 80% is typically, it's conventional for healthier non-stressed rodents. So the dotted lines that I have cutting across the graph here are indicating the 65% and the 80% cutoff values. Now, again, interestingly, and in contrast to our original hypothesis, the refined housed rats again fared worse in terms of their well-being and worsened depression-related behavior relative to those standard housed rats. Refinement rats displayed sucrose preference scores consistent with those that are designated as being anhedonic-like, whereas the rats in the standard housing condition displayed preference scores that were significantly above that 65% cutoff. When we repeated our analysis using the 80% threshold value, or what is considered healthy, we found that the standard housed rats did not differ significantly from this value, whereas the refined housed rats fell significantly below the 80% cutoff. So this led us to conclude that the refined housed rats might be more susceptible to depression or anhedonic-like behavior. Okay, so I was going to quickly rehash the results, but I'll just jump ahead. Basically what we think, because the rats were showing heightened anhedonic-like behavior in both tests, we think that the refinement items in and of themselves may have contributed to an anhedonic-like state within the refined housed rats. This was a bit of a head scratcher for us because they've been implemented so widely in the interest of animal well-being, but we think that they might have contributed to overcrowding within the home cage, which could have worsen their depression-like phenotype. There is evidence within the field to support this hypothesis, as overcrowding can lead to heightened depression-like behavior. However, it doesn't really account for the heightened anxiety-like behavior that we saw by all rats in the novelty-induced suppression of feeding. Upon much reflection, we think that this might be caused by the novel use of independently ventilated cages. Traditionally, we've used ambient ventilation in our laboratory colonies, which you can see on the left side of the screen here, through which the air can flow freely in and out of the cage. By contrast, in this new housing system, the independently ventilated cages are hermetically sealed. And this is really good for transgenic animals or immune-compromised animals, but it basically, in singly housed animals, it contributes to complete social isolation. Now we know by excess literature within the field of neuroscience that social isolation in social animals can contribute to chronic stress and really exacerbate any anxiety or depression-like phenotype. So we believe that within the current study, the rats in both housing conditions were under chronic stress due to complete social isolation caused by the IVCs. And we think that this was then compounded further within the refined housing group due to overcrowding by way of refinement items within the home cage. So in summary, it's really unclear whether these refinements actually do improve the well-being of animals used in research, although the current results do suggest that the crowding by way of refinement items might increase a depression-like phenotype. This finding was potentially confounded by other inadvertent stressors within the home colony, such as these IVCs. It's really crucial that we further understand how these minor changes to the home cage environment can impact laboratory animals' behavior, both to advance the welfare of animals used in neuroscience research and also to ensure that any research efforts within our field aren't being wasted. So that's all that I have. Thanks for listening. I'll be happy to answer any of your questions.
Thank you so much, Samantha. That was really interesting. I'm very happy that you explained a little bit about these IVCs at the end of your talk, because I was getting pretty worried about how we keep rats in the lab. So one thing that I was wondering is, as these IVCs were probably applied to all the rats that participated as subjects in this study, that can't really explain why you see these heightened anxiety behaviors in those rats that had actually these enriched cages.
Yeah, so that is actually a really interesting phenomenon, and it's opened up a new line of research for our lab. Actually, a lot of the undergraduate students that are coming in now are directly comparing the use of the open top cages compared to the IVCs, because within the scope of our study, we really couldn't definitively say one way or the other, this is the cause or not, because we weren't comparing those variables. But our lab now is actually, we're traditionally an anxiety lab, and we look more so at neurodevelopment actually, but it's opened up this new line of inquiry where we're trying to parse out how these different variables, whether it be the caging, the bedding, even the lighting within the home cage system, can influence different behavioral baselines. So I don't know if does that kind of answer your question?
Yeah, no, it does. Thank you so much. So relatedly, is that then where this research is going to go, or is it something that you might say, well, let's compare other rats, because I'm guessing that these rats that you tested now in these different, in the enriched and in the non-enriched cages are coming from the same type of animal, let's say. Is that what you're going to change next, or is it really sticking with the focus on these different cages?
So I believe that the scope of so I'm no longer involved in this project. This was my honors thesis from 2 years ago. But right now what's happening is they are looking more so just at those caging systems. So whether it has to do with the social isolation component of being in a cage that's hermetically sealed, like those independently ventilated cages, versus the ones that do have the open wire top. I kind of had to hustle a little bit at the end there, so I maybe couldn't really describe so well the differences between the two caging systems. But we really believe that what's contributing to it is just that inability to hear or really smell any of the other rats nearby in the colony room. So that is the variable that we're looking at most intensely, for sure.
Okay, thank you so much for clarifying that. I appreciate it. I think